So I'll kick off. We're good, we're live. All right, welcome everyone. Thank you for carving out some time in your afternoon to attend this webinar. This is the second event in Drive Electric's winter series, focusing on megawatt charging, upsizing heavy transport in New Zealand. My name's Sam Steele. I'm on the board of Drive Electric, but by day I am deeply involved in electrifying heavy transport across Europe and the US. So I selfishly put my hand up to host this one, just so I could have a front row seat to listen into our panel today. I want to kick off by thanking our sponsors, Singer Electric and ECA. Without our sponsors, we can't put these events on, and I think it's really important that we're able to get some amazing panelists in front of you all so that they can share their knowledge and what they're doing. Right, we've got quite a packed agenda today. So the way we're going to run through this is we are going to introduce our panelists one by one. They're going to give you 10 minutes of their time to share their knowledge. So we've got two panelists here in Palemia and Hayden, and then we've also got two joining from overseas. So we've got Liz in Wellington and we've got Marc-André from Switzerland. So we're going to run through our panelists who are going to share their presentations with you. And then at the end, all going to plan, we're going to have some time for some Q&A, which is going to be run by ECA's Paul down the end here. If you have questions along the way, please feel free to post those in the webinar chat. We may not be able to get to all of them given how much time we've got today, but we will follow up after the session. So Drive Electric will collate all of those and provide answers from our experts after that. Okay, well, let's kick into it. First up, we're going to have Hayden Dooney presenting. Hayden is from Singer Electric and is one of their EV specialists and has been instrumental in developing the relationships with ABB and AT to get the Auckland Ferry project off the ground. So excited to hear from you, Hayden.
Thanks, Sam. I've just mucked up my screen here, so I just need to get this going again. Sorry, Sam.
That's all right.
So I'll just get our IT man to drop in.
Wouldn't be a webinar without some technical difficulties to kick off.
Exactly. Excellent. Thank you. So thank you to the team at Drive Electric and to Hannah for organising this. It's always a mammoth effort on Hannah's behalf to marshal us all around, make sure we send everything in on time and chase the slow ones like myself. So I'm here today to talk a little bit about the partnership that was formed and the relationship that was formed between ABB and Singer to support AT in their adventure of megawatt charging and electrifying ferries. So a little bit about Singer. Our vision, Singer's vision is connect buildings and transport systems that are energy efficient. Our purpose is the smart electrification of New Zealand, and Singer's mission is to enhance electrical systems daily with our technology. And for us, that's an important part. We're using technology to make things smarter and more usable for everyone out in the world. So I really want to pay a little bit of a homage here to AT in the way that they structured the tender and the way it came out, because they put a lot of thought into it and they actually engaged with suppliers to make sure that they got it the right result. So right in the beginning, there was registration of interest that came out through GETS. And so when we noticed that come out, Singer approached ABB and we had the conversation and decided it was a great opportunity for both of us to submit a joint tender into AT. So as part of the registration we submitted, then AT had a number of workshops as to how the tender should be put together. And what came out of those workshops was the tender came out in 4 different packages. And so what that was there was a design package, a build package, a high voltage package, and a low voltage package. And so Singer and ABB submitted their approach to this, and part of it came to fruition that we were being globally supplied and locally resourced. And you'll find later on in this presentation that was probably one of the standout winning things for Singer moving forward. The project introduces New Zealand's first megawatt charging system This is to support all electric and hybrid electric ferries. This will deliver across 12 different sites throughout Auckland, delivering an impressive 3.3 megawatts of charge at each site. The Megawatt Charging dispensers provide the DC charge, and the e-house is a switch room. It's prefabricated off-site to house the ABB power drive and megawatt chargers. The e-house is fully climate controlled, and a key advantage to the design is the ability to be able to transport and locate across different types of sites. For the people who know a little bit about Auckland, you'll know that every ferry site is not exactly the same. So the ability to be able to have a solution that was adaptable was paramount in this project. So when Singer is looking at a project of this type, Singer looks at the alignment of the project will have with Singer's values. With the AT's commitment to electrify, this will look to reduce diesel use by 1.5 million litres annually and CO2 emissions by 4,000 tonnes. This equates to roughly 6% of Auckland transports, resulting in a 20% reduction in emissions. This really aligns with Singer's core values as we're working with most of our customers to have these sort of results by 2025. When I was meeting with the team from AT Ferries, it was quite, we had quite a conversation with them, and it was interesting for us to try and find out, what was the driving force behind selecting ourselves and selecting ABB in this. And so one of the three things that came out was that megawatt levels of charging enable quick refueling and turnaround and putting electric ferries on par with fossil fuel ones. So for AT, that was an extremely important thing. They wanted a tried and tested equipment that had been installed and provided globally. So ABB has done a project like this in Lisbon, and so we were able to demonstrate the technology and the abilities of ABB and the systems that they would provide for this job. But equally important for AT was that it needed to be locally supported, and so that AT could speak to local supported people with a knowledge of the system. And Singer's been working closely with ABB to actually increase our knowledge in this space and with their products. It was also extremely important to AT to have a proven charging solution, so the ferry customers continue to experience the high level of service that they've received today, but more importantly, that the ferry operators have confidence in the charging equipment. So in short, one of the great comments that was given to me is that AT wanted to have their cake and eat it as well. So this was the strength of the ABB relationship of globally supplied and locally resourced. And that came across in our presentations with AT. So where to next? Well, Megawatt Charging is at infancy, and as Sam's pointed out, it's going to be a global thing, and I know that Liz and Palemia will talk to this through their conversations. Applications where this can be used, we see it being used for shorter ship charging, heavy fleet, bus depot charging, ports and containers that are operating 24/7, and really that is unlimited, and it's about getting experts at your site to have a bit of a look and talk you through what options are available to you. So in closing, where to from here and how Singer can help you? Well, we're globally supplied and locally resourced, so Singer will be happy to meet with you and understand what you're looking for and how we can tailor a solution for your needs. And so with that, I'd like to charge forward and hand back to Sam to introduce the next speaker.
Thanks, Hayden. Really interesting. I think, when you think of electrification of heavy transport, your mind quickly goes to road transport, but it's pretty astounding how much of Auckland transport's emissions you can reduce through
fantastic.
like ferry projects, right? So
yeah.
And someone who could probably speak a bit more about that than I can is Palemia. So Palemia, thanks for coming. I think you were saying you're coming home to visit family, but I really know that you travel all this way to join us on this Drive Electric event. So, yeah, thank you very much. So Palemia is the ferry segment manager at ABB Marines and Ports, based out of Finland. Interestingly, Palemia is also on the sighting commission for European rugby. So as tempting as it might be, please no questions on whether there should have been yellow cards in the weekend's match.
We'll move on.
Yeah, thanks Palemia. Take it away.
Cheers, Sam. And good afternoon, everyone. It's I understand we've got a fair few people online, so thank you for your time, and hopefully this will be quite a interesting change from the normal EV on-road discussion. Hopefully what I'm here to do is to guide you through an exciting exploration of the ferry industry. It really has been evolving quite a lot in the time that I've been involved in the business. It's a sector that's not just critical for transportation, but it's been playing a pivotal role in our global supply chain and logistics. And certainly the pandemic showed that in a lot of regions in the world of just how critical these ferry services were. At first, it might seem that ferries are fairly dull, everyday vessels. But unfortunately, I'm a bit of a ship spotter and I quite enjoy ferries, and that's why I love what I do. They are vital connectors. They link communities, they drive local economies, and the smooth operation of global logistics is actually quite fundamental to what ferries contribute. So I wanted to shed a bit of light on how we contribute to these areas in the ferry segment, what the innovations are going on globally, and we know that we have a lot of challenges coming up that we need to resolve. Hopefully I can work my technology. So really wanted to start with the big picture context. The maritime industry as a whole, and this is not New Zealand, this is the global contribution, is we contribute about 4% to global greenhouse gas emissions. We have to do something about the business. If we were a country, I think we rank around about 6th in the world as an emitter. So this is really something we have to work on. Within the maritime industry, ferries represent about 15,500 ships. I suspect that's a low number because that's just what's been reported in databases. But they're operating in different locations and they contribute, it's expected they contribute about $60 billion to global GDP and also support about 1 million workers' jobs. And already we know that they are a key essential link in the supply chain, especially in regions where other forms of transportation are either limited, non-existent, or just not available. Same again. So consider this. We know that 90% by volume is carried by the marine business around the world. By weight, it's about 70%, but a lot. And many of these goods eventually make their way onto ferries for the final leg of their journey to then be dropped off by a truck for the last several kilometers. We make sure that the goods move seamlessly across rivers, seas, waterways, inland waterways, and they really are quite indispensable to logistics networks. They create a connection from remote locations to trade hubs, and we've seen them transport raw materials to finished products, as well as people, their cars, and connecting the communities. Being part Samoan, I know the importance of an island community relying on regular ferry services to get the daily necessities, get people to their work, to medical appointments, or to also feed industrial centres with raw materials and take away those finished goods, heavy machinery, so on and so forth. So really, I tend to brag about ferries being the unsung heroes because everybody takes them a little bit for granted. But a great example for this is a route that's been operating since the 11th century, running between Helsingør in Denmark and Helsingborg in Sweden. It's a 20-minute crossing. The ferries carry trucks, articulated lorries, buses, cars. They were designed to carry trains between the two locations. And it's really not a convenience. It's a critical link between Sweden on the northern side and Denmark, which allows access to the rest of the European market. It's a crucial route, and we had a big storm in the Baltic where the bridge, if anyone's into the Nordic noir drama, that bridge had to be closed down, but the ferries kept on going and they were the last transport link still in service, even in foul conditions. So what we do know, if we talk about the future of ferries and how they're evolving and the demands that's going on, and really to plug into what Hayden said earlier, is that we know that the number of battery ships is increasing. Now, the graph that you're seeing on there is quite a small number when you consider the absolute number of vessels in the world. But what's significant about ferries is that ferries represent about 40% of those ships that are either in operation with batteries or on order. And that's only up until 2027 because that's the data I have available. What we're seeing already is post 2027, a new ferries, and every single ferry project that we've been involved in and discussing with clients now involves some form of hybridization or full electric operation. So one of the really cool projects that we've been involved with which got delivered during COVID, which was unfortunate because it's a tourist boat. I'm a little bit passionate about this because I went on this when I was a 6-year-old with my parents and still have the photos of the old Maid of the Mist boats. So the Maid of the Mist is a route for the Niagara Falls. It's a tourist view. Traditionally, you had these diesel boats that would take you up to the Niagara Falls, but most of the times you couldn't hear them. You'd just hear the diesels running. We were contracted to deliver fully electric systems for these new ferries. So the Maid of the Mist vessels carry millions of people per year to see the Niagara Falls up close and personal. Now, what's really great about this, and it's a fantastic story, is that they are charged with hydroelectricity that's generated by the falls that they're there to watch. It is an amazing experience. The boat, there is no vibration, there's no sound. So all you really get them involved in the experience of seeing the Niagara Falls. It's a really good example of how a traditional route, traditional business can embrace this innovation and create something that's really, really quite extraordinary. Then, for fully electric and hybrid vessels, such as those planned in Washington State, as a sidebar, if anyone thinks they look vaguely familiar, yes, these are the ferries from the opening credits of Grey's Anatomy. We're not just talking about reducing emissions, but we need the reliability and the links between communities. But we want to be able to do that in a way that we're not going to affect the environment. So with the vessels that we've now got the contract for in Washington State, with shore power, with shore charging, they're going to reduce their emissions by 75%. This is massive. It allows the system to stay resilient. It allows it to be there and still minimize its impact on the environment. Finally, a third example I want to give here is for the Dover-Calais route. This is the P&O ferries, 2 ferries that were built and delivered over the last couple of years. These are the world's largest double-ended ferries. They're 230 meters long. They have a battery pack on board of 8.8 megawatt hours, which allows them to also moor in alongside actually just on batteries in most conditions. And they contribute to the fact that those ships have reduced their fuel consumption by 40% compared to the previous class of vessel. So it's not just about the emissions, but it's also cost savings with the CO2 emissions taxes now present in Europe and in the UK. And also for the passengers, a lot of them don't even realize they've left Dover or Calais because it's so quiet, so silent. So the resilience on that link now has really been increased with the multiple fuel or energy sources on board. So it's not just about technology, it's about the resilience of the logistics networks. We want the smooth transit of goods across waters. And generally what we're dealing with is we're trying to decongest the highways. So we're taking, providing an alternative route where it's impractical, too expensive, or there's just too much strain. And what we can see with a lot of these, they're now sort of offering different services on board. A wee bit of a history lesson, and I'll be quick. We're not talking about a flash in the pan shift. This has been something that's been developing over the last 30 years in different guises. We did start with shore connections for cruise ships to be able to shut down the diesel engines while they were in port. That was in the 90s. And when I was an engineer on cruise ships, it's a really weird feeling walking through an engine space that is dead quiet, but you've still got all the lights and you've still got all the AC running, which means passengers don't complain. So it's a really bizarre feeling. But we've seen that codification for shore connection and cold ironing with the IEC. So now we have global standards that we can apply. What we're seeing now is the demand to standardize charging of batteries and being able to enable hybrid hybridization as opposed to just switching your hotel load across. And that's why we're particularly excited about this MCS protocol, which speakers later on are going to talk on. And I suspect, to steal my father's line, I'm preaching to the choir. But we also map out something quite similar when it comes to time available to charge and power demand, so that we can calculate how much energy needs to be transferred. So we've put all these boxes up just to say the different segments and where we see they might need it. And then if we overlay a grey box that sort of indicates the megawatt charging system where that could support us, you can see that's actually quite a few segments covered off quite nicely. And I'm going to use New Zealand example first, because I think Sparky is quite an important discussion point. So the Darman built tug for Port of Auckland. We get lots of questions. First off, do you normally name your boats like that? Second off is, how does she charge? It takes a while to charge Sparky. She's got 4, I believe they're CCS connections that will deliver a 1.5 megawatt of power over time. On the other hand, we've got the Lisbon ferries that Hayden alluded to, which, if you can see on this really small screen, you see there's a tower right in the corner there, and I don't think I can, there we go, there, that one, hopefully. It's an autonomous tower. It's an automatic tower that will drop a custom designed plug into the socket on board the ferry and deliver around about the same power as what we're going to do here in Auckland. At the upper end of the scale, we need to step it up a little bit and start bringing in robotic charging, bigger pantograph solutions. And this is the charging solution for the Swedish, better get this right, Danish ferries, where we're using an industrial robot to pick up the plugs, plug them in, and deliver, I think from memory, I've got it written down, 1.2 megawatt hours of energy in 7 minutes of charging. Just to give you an idea of some of the scales involved. But as you can see, this is quite a complex topic. There's a lot of moving parts, but we're really hoping that the megawatt charging system can reduce the barriers of entry for more electric ferries and really trying to sustain us for a more cleaner future. Now, I can't go through this without talking about Auckland Transport, because I'm super proud about this. I worked for Fuller's as a high school student in Auckland, and I'm super proud of what we're doing here with Singer. I apologize, it's not Singer's name on the slide, but this is something I stole from one of my colleagues who was using this as a reference at other conferences. So we are very proud about this project. We're promoting it abroad. It's a significant project that we are able to deliver something with so much power that's available that can be handled by a single crew member. And it remains to be safe, and we're going to get it delivered. So on that note, hopefully I've put across that I'm pretty enthusiastic on ferries. I'm pretty excited about them. They are extremely vital cogs in the global supply chain machine. They drive economies, they connect communities, and they are leading the change. So I look forward to how we're going to do more in this space. I look forward to other industries taking up the lead on MCS charging so that we can all get cheaper solutions maybe in the future, or more standard solutions, which means that we can also do better with the onboard systems. So back to you.
Awesome. Thanks, Palemia. Really impressive. I hadn't quite appreciated how much activity was going on in the electrification of the ferry space.
Yeah.
Despite the technological barriers, especially from the infrastructure side, you talked about requiring kind of autonomous pieces to help the kind of level of charge that some of these vehicles need to be able to operate. And I think our next speaker is probably perfect to be able to speak to some of that. So we're taking the webinar global, provided the technology permits. And we're going to beam across to Marc-André in Switzerland, who's the CEO of Grivix. And if you're wondering, we're talking about megawatt charging, but you're wondering how fast can we go? Marc-André is working on technology that can deliver 6 megawatts and above of charge. So really impressive charge rates, and of course with that requires some autonomy and other bits and pieces. So Marc-André, I'll let you take it away.
Yeah, good morning, everyone. And I'm already sorry for my background, but I already was in the way to my office. And then on halfway, I realized, oh, I forgot my keys in the office yesterday, and it's quite early. So I needed to go back to my garden to hold this speech. But on the other side, you get a nice Swiss background of Swiss mountains, if you can see them. It's maybe a little bit cloudy. So honestly, I know nothing about ferries, but I know a lot of things about cooled cables and high power, high current technologies. And what you can already see here on the first slide is our specialized version that we are using for mining with a higher ceiling that we is already starting to be deployed. That's an MCS cable that we are running currently at up to 6 megawatt. So short introduction about Grivix, and I really keep it short, but I think we are not that as famous as ABB yet. We are developing cooled cable technology, so we are a technology leader in this field. I myself, I'm in automotive technologies since more than 14 years. So basically, this was before Tesla was on the road, if I'm correct. So back then we were still ripping out combustion engines out of vehicles and putting in electric drivetrains. We are doing simulation. We are doing vision recognition to identify the vehicles, the connectors at the vehicle site, and fully automatically plug in with our robot technology, and then finally charge at 6 megawatt. So a little bit of a background about fast charging. There's always a bottleneck, whether it's the source of the energy, that's the grid, where whether it's a sink, where the battery, or the means in between. So in the past, it was mostly the batteries that were the bottleneck, but looking at the growth of the charge rate with batteries that we had over the last 15 years, and the charge rate grew by 15 times. So that was like in 2012 with a Leaf to a passenger car nowadays that can charge at 180 kilowatt. I don't want to say that this growth will go on like that forcefully, but there's a good chance. Also, there are already startups that do charge at 60C. So that means that batteries can already be charged in 1 minute. Currently, we are talking about 3C. That's the normal case. That's charging of batteries in roughly 20 minutes. And in mining with specialized batteries, we are already fully charging batteries at 6C, so between 6 and 10 minutes. But keep in mind, we are talking about infrastructure here. So whatever we deploy right now needs also to deal with batteries that will get to the market in 15 years. So if you're talking about the startup that is currently charging at 60C, that's not on the market yet, but it will be in 5 to 8 years. So that the infrastructure that we are planning and are deploying now needs also to deal with this technology that comes already in the near future. So what do we need, or how fast do we really need to charge? Currently, we are at 200 kilowatt for a Tesla. We roughly need 1.5 megawatt for current electric trucks that are on the market. Here, that's an e-Force. It's an electric truck out of Switzerland. In mining, we have the need of up to 12 megawatt charging. And here's just an example of a ferry. As I said, I'm no specialist for ferries, but I got requests from companies in this range that are asking for 60 megawatt up to 90 megawatt of charging. So for the connectors, for the standards that we have right now, we get to the limit. So with MCS and ruggedized MCS, that's the cable I showed you before, we will achieve roughly 6 megawatt, and we need to deploy something new in the future if we want to go for a charge rate up to 60 megawatt, as it was mentioned in the discussion before. Of course, we can also do that all uncooled, and I just want to give a little bit of a idea what this means. So in the current CCS cables that are cooled, that you can already find at the highway in Europe at Ionity, or in the US at Electrify America. Sorry, I don't know what are the charging stations in New Zealand. But they have a dimension of 34 square millimeters and the weight 1.4 kilo per meter. So it's a quite lightweight, flexible cable. If we would do that all uncooled, it would be roughly 5 kilogram per meter. Now, if you're talking about MCS charging, there we have currently cables that are charging at up to 4,000 amps, have a dimension, cross-section, a diameter of 50 millimeter, and roughly 4 kilogram per meter, which is already quite heavy. But thinking of doing in all uncooled without cooling technology, then we would be at 18 centimeters with 23 kilogram per meter. So the cable wouldn't be really handleable anymore. So that's why we are using cooled cable technology. I have a very short video where it shows it very well, what it means to cool cable and what extreme high currents can be transferred thanks to that. So on the panel on the back side, you see a 4 in the right panel. That's the current is running currently. That's I put 4,000 amps here. That's what's shown here. You see these huge copper bars. And the video is without sound. It doesn't really matter. But I want to show you that you have an idea how small cooled cables can be. So you see the huge copper bars, then you see the huge copper cables. That's all the testing setup that we have with the cooling unit, which we unfortunately cannot show. And then you see these super thin lines that we have for the cooled cables. This is already 2 years ago, this testing, so our technology has a little bit evolved. And also to give you a comparison what it means going from MCS to gasoline. So on the left side, we have a gasoline station. On the right side, that's me in Perth. What does it mean charging with gasoline? At the usual gasoline station, you charge at 23 liters per minute with a regular pump. It gives you a caloric value of 13 megawatt. And then, depending on the motor you have an efficiency of 20 to 30%. For boats, it's usually higher because they're running in at the ideal moment. Sorry, don't know the right English word. So we have roughly 2.6 megawatt, maybe higher for boats. And with MCS, we are already at more than 3 megawatt. And with ruggedized MCS, we can already charge at 6 megawatt, which is quite already higher and better than gasoline stations. So a little bit of an outlook where we will go from here. Cooled cables, as we see them nowadays, the technology cannot go on like that. We are getting to our limits. For if you want to go for even higher currents or higher power, we would need to increase the voltage, and that means we need to automate things. So after MCS, probably the next step or the next evolvement will be automation. That's also the other thing that our company is doing. So the big question remains, is 6 megawatt going to be enough for the future, or do we need to have more? I guess if I look at the ferries and the requirements that we've seen before, it will be needed, more will be needed. So a little bit of a wrap up of what I said. Today's infrastructure needs also deal with the vehicles and batteries that we have in 50 years. Keep that in mind. Don't under-design your infrastructure. Rollout of MCS started, at least here in Europe, and we are more than happy to support you in your fast charging projects with cooled cable technology or automation. Thank you.
bottom on the left. There we go.
There we go. Very good. Thanks, Marc-André. So we're just getting unmuted here. Really interesting to see some of the technical details involved in solving some of these infrastructure challenges to delivering those charge rates. So hopefully we on the panel here are the only ones kind of nerding out on some of those technical details. And I certainly wouldn't want to be the one operating a 23 kilogram per meter of cable to try and plug that thing in. So yeah, thank you very much for that. Clearly, we're talking about innovation projects as examples of using these megawatt charging solutions, but for this to become scalable and enable more and more sectors and customers of this type of technology use it at scale, we need to be able to focus on standardizing and productizing those solutions. So we've got Liz Yeaman, who probably doesn't really need an introduction from us here at Drive Electric as a kind of leading expert in New Zealand and the managing director for CharIn. So Liz, I believe you're going to talk to us about kind of MCS and the standardization of it to help make it more accessible to everyone. Liz, take it away.
Thank you very much, and hello to everybody. Just sharing my screen. Hopefully you can all see that. So yes, I'm going to talk about the process that CharIn has gone through with the development of the megawatt charging system. For those that don't know, and CharIn is probably not that a familiar name in New Zealand
Sorry,
yet.
Liz. Just step in there. We can't see your share screen at the moment.
Right.
Would you be able to just double check that?
Yep, it's telling me that it's being shared. How is that now?
We've got that now. Thank you.
You've got that now. So a little bit about CharIn, which is the Charging Interface Initiative. We are a non-for-profit association that has global membership, that together all our members come together and promote interoperability of charging, which is really key, that we move beyond just proprietary solutions where one charger works with one vehicle to have everything together. So it defines the requirements. We are the organisation that has developed the CCS2 charging standard and CCS1 that's used in the States, but CCS2 here in New Zealand and most of the rest of the world, the Megawatt Charging system, and also behind ISO 15118, which is the standard for the communication protocol between vehicles and charging infrastructure. We have offices around the world, and I'm now the representative for Australia and New Zealand. Is that moving on? Because my one isn't, unfortunately.
We can come. Yep, there we go.
So we have about 300 members globally. They are big companies as well as some small ones. So most of the major OEMs are members of CharIn. All the ones that you would expect, Toyota, Tesla, all the other the makers and so on, and that's increasing all the time. Charge point operators, they are the companies that provide charging infrastructure, public charging infrastructure for people to use. The EVSE, that's the electric vehicle supply equipment, those are the chargers themselves. So a lot of the charger manufacturers are our members. The e-mobility service providers, those are the companies that actually do things like bill you for charging, and might do management of fleets and so on in the background. Grid operators and energy providers, the standards and testing organizations, and the components subcompile, the people that provide the plugs and the cables and the other parts of chargers and vehicles. So whilst CharIn started in 2015 in the automotive sector, we've gradually moved through to look more at truck charging, bus charging, and now we're looking at mining, marine, and aviation is one of the next things that's going to be coming off the block as well. So it's about one interoperable system for all, underpinning all of those different types of charging from CCS2 through to MCS and the future is the ISO 15118 charging protocol. At the moment here in New Zealand, we can see public charging, which is both fast charging and high power charging. As we move into the megawatt charging system, there has to be a different plug type that will come along, but the charging protocol remains the same underneath. That means that you will see trucks which will have both a CCS2 port and an MCS port. It can charge, say, CCS2 at a truck depot or a bus depot, and then MCS when it's out on the road at public charging infrastructure. And in the future, as Marc-André has anticipated, we are looking at the next level of charging, which is being called extreme MCS. We don't know what that plug type will look at, but it will still work on that ISO 15118 charging protocol. And it could be from 6 megawatts, which would be 12 megawatts, which would be 2 6-megawatt cables, up to 40, 50, maybe even 60 megawatts. That's yet to be determined. And we're now looking, of course, at all sectors for that. So some key design features of MCS. There are actually 3 levels of MCS. So what they are looking for the Auckland ferries is level 3 MCS, but level 1 is probably what we will see on the first trucks that come with MCS to New Zealand. So that can have an uncooled cable and it can have an uncooled inlet, as the maximum current is 350 amps. As you move on to level 2, that's up to 1,000 amps. You must have a cooled cable by then, but you can still get away with an uncooled inlet. But in level 3, you need both a cooled cable and an uncooled cable to allow that current to flow at up to 3,000 amps. So putting that together with the voltage, the minimum voltage requirement for MCS is 500 volts DC, and 1,250 is the upper limit for a handheld connector. That will give you 3.75 megawatts of power, and internationally that's acceptable for a handheld connector. Once you get above that, you have to have a fully automated connector with no human touch on it. And for megawatts, you can have up to 1,500 volts there, so you could have up to 4.5 megawatts with the current system. Like I said, the ISO 15118 charging protocol is what underpins everything. It's what gives cyber security to the whole system. You've got not only power flowing, but you have money flowing in financial exchanges. You have data flowing that you need to keep secure. You will have grid interactions, which also need to be secure, connecting into electricity networks and so on. So that's a key part of that communications protocol, and it allows for all of those different things to happen, not just the car talking to the charger, but the whole system meshing in with payment, with feeds into fleet management and e-mobility providers, and in the future increasingly to grid and grid interactions as well, so that you could have a grid, for example, sending a message saying, actually, we've got a real constraint at the moment, can you slow the charging down? Or alternatively saying, hey, we're really cheap, we've got plenty of power at the moment, dial everything up to the maximum while the going's good. So the MCS standard, the MCS, the megawatt charging system is being standardized at the moment. It's going through that process with ISO, with IEC, and with SAE. That standardization process is fixed and quite a lengthy process. What CharIn does is help bring global experts from industries together to help shorten that process of standardization as much as possible. Ahead of entering the standardization process, they get together, they define the scope, they define what testing they need to do. They can come together outside of that process and agree on what should be in the standards, and then it goes through the standardization process. So we're coming towards the end of that at the moment. There'll be a lot of publication happening this year. The latest it can happen by is 2025. So we will start to see, and already those CharIn members who have been part of that group are fully aware of what is going to be in those standards and can start progressing those to market solutions right now. And we're likely to see mass production solutions coming on in 2025. So we've talked quite a bit about ferries. I thought I would mention about trucks. For MCS for trucks, like I said, it's likely to be level 1, at the most level 2 MCS. Trucks that have said that they will be bringing, truck OEMs that have said that they will be bringing trucks to New Zealand with an option for MCS charging include Scania, Mercedes-Benz e-Actros and Windrose, and there will be others as well. Those are the ones that have declared that they will be having that as an option. One of the important things is that through the standardization process, they've actually specified where on the vehicle the inlet will be for MCS truck charging. And it doesn't matter whether you're right-hand drive or left-hand drive, it will be on the left-hand side of the vehicle, behind the frontmost axle, and there's a distance specification that it must fall within. That will allow you to design public charging stations with MCS in advance without having to worry too much about how the truck is going to pull in and use those. And as Marc-André has alluded to, there are more developments with MCS coming. His group he's been the leader of the CharIn group for ruggedized MCS, which is specifically for the mining industry, which looks at making sure that that can work in extreme environments where there's lots of heat and lots of dirt and lots of dust. And the next thing off the block after that, again, largely driven by the demands initially from the mining industry, but also with real relevance to marine and aviation, is the development of extreme MCS, XMCS, which is the whole level again. CharIn is currently starting up a task force marine, and I encourage you to have a look at the CharIn website if you want to be a part of that will scope and take industry operators, including ferry operators and shipping operators, in to help define what they need out of that. So that is the next task force that's coming from CharIn, specifically looking at the marine industry. So thanks very much. You can get in touch with me, and there's a QR code there to quickly find out more about CharIn. Thank you.
All right. Are we back on here? Very good. Thank you very much, Liz. Really interesting, and looking forward to seeing the advancements on standardization of MCS over the next couple of years, and see more of these projects come online. Well, thank you to our panel speakers for those sessions, and also for being on time. I think that's the first webinar I've seen us run like clockwork, which Marc-André, you could appreciate. We're now going to move to the Q&A portion, so I'm going to introduce Paul Bull from ECA, but I have a sneaking suspicion he's going to kick off with an announcement and then roll into the Q&A.
An announcement. An announcement, but like, why is ECA here facilitating the Q&A? It's great to see Liz put some questions up, put some pictures up and show some trucks and talk about megawatt charging for trucks. ECA's out in the market at the moment with supplier ITR to register low emission heavy vehicles, 5.9 tonne and above. So if you're online and you haven't seen the ITR, get on, get that information, get it in. Minister of Transport's super excited about the fund and is looking to launch the fund as soon as he's got a day in his diary, and we've got enough panel members there to stand it up, which means you can start ordering your trucks or your truck conversion if it's applicable, and start getting them on the road when they arrive. And megawatt charging is going to be an important part of that. Low Emission Transport Fund still continues on, and so it's there to help demonstrate those first opportunities for different technologies in that space. A mining truck at OceanaGold is a good example of stepping into that space. I was interested that the nerdy questions on, the guys are getting excited about the nerdy stuff at this end. And so I'm probably going to ask the panel members to unnerdy some of the stuff. And Liz, I'm going to start with you. Can you please explain the difference between the existing fast charger technology and the new megawatt charger system, particularly given your reference to only some of the trucks will be coming in to NZ with megawatt charging facilities in them?
It will be an option for trucks. I think a lot of trucks will, particularly trucks used in New Zealand. I think people think that all trucks are huge, big 40-ton plus vehicles that drive from Auckland to Wellington. In fact, the majority of trucks that we use every day are smaller trucks that go no more than 200 kilometers a day, often only 100 kilometers a day. And those are starting to be able to be served by the technology and the CCS2 charging that's available today. So we're only talking, and I think that will be the option that will remain there for that size of truck. For as we move towards bigger and bigger electric trucks, they will need higher power, particularly if they're driving long distances, so that a driver can recharge during their half-hour rest break every 5.5 hours in New Zealand. In Europe, I think it's every 4.5 hours. So that's when megawatt charging starts to come in. In fact, even in New Zealand, we have limited opportunities for that because you can really only drive about 750 kilometers without running out of island to drive on here. But we will see that coming in, particularly for trucks that need to do those really long full island distances and recharge in driver's breaks. And that will start coming in. So you will see trucks continue to coming in with just CCS2, but then additionally with MCS as an additional option. I think for charging at depots, CCS2 will be what will continue to be. It doesn't make sense to have that level of power and the additional expense of MCS if you don't need to use it, but it will be there as a supplement. It will be a little bit like at the moment for cars, where people have AC charging for overnight, but when they do a longer journey, they can DC charge en route to get to the end of their longer journey. It will be like that. Depot charging will be CCS2 and MCS will be used for those longer distances.
Thanks, Liz. Good answer. Marc-André, I'm going to cut to you for a supplementary or a second question. So the guys were quite excited about the size and the weight of the cables. And then Liz talked about amps, and if you're a non-technical person trying to understand the difference between the two. So my question is, how fast will charging get? And I guess looking for you to decode the technical stuff into the non-technical for the non-technicals online. You're on mute, mate.
Yeah, that's the most said phrase since COVID, right? I'm not just going to be here. Yeah. The question is how fast charge can be.
Yeah. How fast will it get in the future?
How much you pay my company? how fast you want it to be? No, I mean, there are certain limitations. I would say a good compromise for a big next step would be 15,000 amps to 4,000 volt. That's still a connector that can be manageable even by a person by an trained operator, but can charge it up to 60 megawatt and would mostly be operated by robots. That's what I see as the big next step. There are definitely limits with the current. So right now, what we did till now with the cooled cables, we were not increasing the voltage, because that's a risk for a human operator. We were always increasing the current, and increasing the current is you take copper, but you cannot take more copper because it's getting too heavy. So you're cooling it, and of course you can cool away a lot, but at some point it becomes unreasonable. So at some point you start building bigger cooling towers than power electronics. I mean, you can cool it all away. I mean, hypothetically, I could use a super small thin cable and just have a huge cooling tower next to it and run it at at 10,000 amps. That's absolutely possible. But then it's the question: does that still make commercially and technically sense? I don't think so. So going back to what I said before, I think a good big compromise will be 50,000 amps at 4,000 volt as the next big step for XMCS.
Thanks, Marc-André. Any comments from the guys here?
Probably Palemia.
I think that, at least in the ferry segment, the big impetus for electric ferries as well is that the current standard of service has to remain the same as the current timetable. So that's really what we put the pressure on companies like Marc-André's, but we don't want to pay that money. So that's why we go through these standards, so that we can, when we start doing these discussions with owners about investments on new hulls, based on an operational profile and then seeing how much they want to have the batteries on board, that will be the discussion that will drive the power range. And that was particularly with ATs, when we started talking about this with Singer and understanding the AT demand. We had some really good boundary conditions, that it needed to be a manual connection. It needed to be, we were told quite early on, you needed to be able to transfer 7 minutes of, you could assume you had 7 minutes of connection time. We needed a maximum voltage range for safety, but then there's a fixed. So we had all of these benchmarks that we could then go back and say, well, this is how much energy we can transfer. If you want more, we need more time, or we need more power, we need more grid demand, so on and so forth. And I think someone's asked a question here as well about using high capacity batteries or supercapacitors shoreside to help boost the energy. And that was something we looked at for this project. In this particular use case, we didn't need it. So there is the ability to integrate that sort of technology shoreside, or if there's, one of the things we're starting to investigate is shoreside hydrogen fuel cells to support the grid where it's weak. And so those sorts of things can be done. And it's good for the boat, because the boat just has to deal with electricity, whereas we can put all the complexity ashore. But yeah, it's how long's a piece of string? How much can you give us, and what can we work with? Yeah, exactly. And it depends who's gone fishing.
Yeah, which is probably a nice segue into the next question, which I suspect might be the last one in this forum. Aside from the equipment and the vehicle technology, what are the main barriers to deploying megawatt chargers? And I'll open that up to all 4 panel members.
Do you want to start with the people online, or do you trust Hayden and me to not monopolize?
Dive in.
I think probably the ability to be able to actually access the required amount of energy to be able to transfer it. And I think New Zealand's infrastructure probably has a bit of a way to go to be able to achieve that. And there's a cost to it. So I think, really that's something that needs to be looked at and discussed at a point, because there is going to be the demand with trucks coming online. The cost of actually putting these systems in will be determined, and how much energy can be transferred by what we can actually attach to for getting energy.
Well, I mean, for me, you've seen the different types of ferries that are out there, and one of the more exciting things about MPS is sort of approaching this the same way as like the USB standard when that came out. If you look at the back of computers from the early century, there was a round port for keyboards, round port for loads of round ports and parallel ports, and I just see our IT guy off camera just nodding his head frantically. Whereas now with USB, the old USB can only go 3 ways, or 2 times wrong and 1 right way, and now we've got USB-C, so there's an evolution over time. And we've all got computers now that have the ability to plug almost anything to everywhere. So for me, the exciting thing about MCS is not so much the back end part of it. It's just that interface between shore and sea across that way. And it allows us to do this innovation both on board and ashore. So, I mean, stabilizing grids, getting enough power to charge anything in a harbor is difficult, because we're normally at the end, as we've seen in some projects, we're normally at the end of a tenuous grid. So we always have to do something to stabilize and strengthen the grid at the local level, irrespective of if it's MCS or some custom plug for a ferry, because that's one of the issues that surrounds shore power anywhere in the world. But the flip side is people want to decarbonize. They want the noise in communities to stop. So there has to be this understanding that here's the technology to do it. You now need to make a decision on infrastructure. So now the choke point is no longer the boats, it's no longer the people on there. It is very much, like Hayden said, an infrastructural question. But we're very happy that we don't have to solve the problem of what's the plug look like. That's done.
Thank you.
Thanks, Liz.
Liz, Marc-André?
Yeah, I think, having had the experience of being involved in the Wellington Electric Ferry project, where that ferry has been running for a couple of years now, one of the challenges is actually where you have that very peaky demand is actually working out how you can manage those costs of the lines companies. And so I think the having a battery energy storage system as part of that solution for charging will be quite important and will enable really good management. It'll be able to let you buy power while it's cheap, deliver it to the ferry whenever you want at rates that won't end up breaking the bank, and also provide some grid support as well. So I think battery energy storage systems, and there's some other technologies as well that are really interesting that can come along that can provide new solutions.
Thanks, Liz. Marc-André?
I think Liz said it all, so we can stay in time. Nothing to add.
Well done.
Close, Wes.
To you.
Well done. Well done. Thank you, Marc-André, and thanks, Paul. Really great. Really good to see the level of engagement coming through on the chat. So thank you everyone for attending and taking the time, and please post any final questions you might have, because Drive Electric will harvest those, and we'll talk to the experts we've got here, and we'll come back to you with some answers to some of those questions. Look, I want to close out by again thanking our sponsors, Singer Electric and ECA, for putting this event on. It's amazing to be able to see some of the cutting edge technology that is taking shape in the heavy transport sector, and seeing New Zealand having innovation projects that are leading that on the global stage is really cool. So thank you very much. Also to our panelists, again, timing was amazing, but also for just taking your time and joining us from wherever you were, or flying out here to share your insights. So thank you very much for taking the time to do that. Finally, clearly we're at the very start line of electrification and heavy transport. There's a whole sector and market in New Zealand that's keen to do their bit, and Drive Electric are clearly keen to be a part of that. So if you want to be part of that conversation, if you want to hear more about what's going on or be involved in these events, then please go to the website, sign up, get involved. Otherwise you'll be invisible. So thank you very much, everyone.
Thanks,
Close
Dan.
out the webinar.
That's it.
Thank you.